A person standing on the granite shore of Back Bay in late August sees gray water, birch trees, and a gravel road winding north toward the tree line. The air smells of damp silt and pine needle litter. There is no sound except the low rattle of a diesel generator operating near a corrugated metal shed. 30 meters beneath that gravel road sits 237,000 tons of water-soluble arsenic trioxide dust. What is remarkable about this accumulation is not its sheer volume, but that geological surveys and mining engineers spent decades passing directly over the site without recording a single indication of chemical leakage. How many other administrative divisions across Canada contain hidden industrial legacies that quietly alter the ground beneath them? Before this examination finishes, it will trace a radioactive watershed resting in northern Ontario and flooded subsea mine shafts extending 3 kilometers under Conception Bay in Newfoundland. For over a century, official planning documents treated northern geography as an infinite buffer, assuming that distance alone would neutralize whatever was left in the ground. That assumption was entirely logical when regional surveys began in the late 19th century, because the sheer mass of the Canadian Shield seemed capable of absorbing any industrial residue. The first crack in that logic appeared when temperature records showed that frozen rock was not a permanent containment vessel. Item 13. The Northwest Territories. In 1948, roasting operations began at Giant Mine on the northern shore of Great Slave Lake to extract gold bound within arsenopyrite ore. The process released gaseous arsenic trioxide, which collected in particulate form inside the mill stacks. Between 1948 and 1999, operators captured this dust and pumped it into 14 excavated underground chambers carved directly into the permafrost. The engineering plan relied on natural ground freezing to keep the trioxide immobilized forever. By the time mining ceased in 2004, the chambers held 237,000 tons of arsenic trioxide dust, a quantity sufficient to contaminate regional water supplies if the surrounding bedrock warmed above 0 degrees Celsius. In response, Environment and Climate Change Canada, alongside Crown Indigenous Relations and Northern Affairs Canada, initiated the Freeze Wall project. Engineers installed over 500 thermosiphons, passive heat pipes filled with pressurized carbon dioxide, driven 50 meters deep into the rock. These tubes draw thermal energy out of the ground during winter, locking the chambers in artificial permafrost at -10 degrees Celsius. The site requires continuous mechanical monitoring, turning a former gold mine into a perpetual refrigeration facility on the edge of Yellowknife. Item 12. The Yukon. In 1969, the open-pit Faro mine began producing lead and zinc in the Anvil Range, 40 kilometers north of the Pelly River. Over 3 decades of operation, the facility generated 70 million tons of mill tailings and 320 million tons of waste rock containing high concentrations of iron pyrite. When exposed to oxygen and rain, the pyrite oxidizes, generating sulfuric acid that leaches heavy metals directly into the Rose Creek drainage basin. The mine owner declared bankruptcy in 1998, leaving the site under the management of the Government of Yukon and Indigenous and Northern Affairs Canada. Today, water treatment plants on the property process over 4 million cubic meters of acid rock drainage each year, adding lime to neutralize the liquid before it reaches the Pelly River watershed. The technical challenge is not historical remediation, but continuous hydraulic control. If active pumping stops for even a few weeks during the spring freshet, heavy metal concentrations in local waterways exceed Canadian Council of Ministers of the Environment protection thresholds by factors of 50. Item 11. Nunavut. Between 1955 and 1957, construction crews built 63 radar stations across the 69th parallel to form the Distant Early Warning Line. Stations CAM-M at Gladman Point and FOX-M at Sanarajak operated high-power radar transmitters powered by diesel generators, requiring heavy industrial lubricants and transformer fluids. When the stations were decommissioned or modernized by the Department of National Defense in the late 1980s, environmental assessments revealed widespread soil contamination. Decades of routine spills and waste disposal had left soil saturated with polychlorinated biphenyls at concentrations exceeding 500 milligrams per kilogram, 10 times the threshold for hazardous waste under Canadian environmental regulations. Because permafrost prevents deep percolation, the contaminants remained concentrated in the active thaw layer, where meltwater transported them into Arctic freshwater ponds used by migratory birds and local Inuit harvesting teams. Between 1996 and 2014, remediation crews excavated over 300,000 cubic meters of contaminated soil across Nunavut, sealing low-level material in engineered gravel landfills and shipping high-concentration soil south for high-temperature incineration. Item 10. British Columbia. Mount Meager sits 98 kilometers northwest of Pemberton in the Coast Mountains, forming part of the Garibaldi volcanic belt. On August 6, 2010, 48 million cubic meters of rock detached from the south face of Mount Meager, creating the largest recorded landslide in Canadian history. The rockfall descended 2,000 vertical meters, crossed the Meager Creek Valley, and traveled nearly 13 kilometers down the Lillooet River Valley. The primary trigger was long-term slope degradation driven by glacial retreat and permafrost degradation within the volcanic core. Subsequent monitoring by the Geological Survey of Canada revealed that high geothermal heat flux continues to melt internal ice lenses within the volcanic edifice. In 2016, researchers documented fumaroles venting hydrogen sulfide and carbon dioxide through the ice cap at the summit crater. Volcanologists calculate that a major collapse could dam the Lillooet River, creating a transient lake that poses outburst flood risks to downstream communities in the Pemberton Valley. Item 9. Alberta. The Suffield National Wildlife Area encompasses 458 square kilometers of contiguous native prairie in southeastern Alberta, entirely enclosed within Canadian Forces Base Suffield. Established in 1971 under a joint agreement between Environment and Climate Change Canada and the Department of National Defence, the site was preserved from agricultural cultivation because military live-fire exercises restricted civilian access. Geological surveys show the reserve contains undisturbed glacial hummocky moraine and sand dunes that preserve the original post-glacial ecosystem of the northern Great Plains. Beneath this surface lie shallow natural gas reservoirs tapped by over 1,000 petroleum wells drilled before environmental protections intensified. The ongoing management challenge involves balancing military operations and legacy energy infrastructure against the preservation of critical habitat for 19 species at risk, including the burrowing owl and Ord's kangaroo rat. Item 8. Saskatchewan. The Athabasca Basin in northern Saskatchewan covers roughly 100,000 square kilometers of Precambrian sandstone overlying crystalline basement rock. Between 1.7 and 1.75 billion years ago, hydrothermal fluids circulating along basement fault lines deposited high-grade pitchblende ore at the unconformity boundary. Deposits like Cigar Lake and MacArthur River hold uranium concentrations exceeding 15% uranium oxide, nearly 100 times the global average for commercial mines. Because these high-grade ore bodies sit within water-saturated sandstone beneath 200 to 600 meters of overburden, conventional underground mining proved impossible without ground freezing. Operators drill freeze holes around the ore bodies and circulate brine at minus 30 degrees Celsius for up to a year, forming an impermeable ice wall that prevents groundwater inflow before extraction can begin using remote jet boring systems. Item 7. Manitoba. In the southwest corner of Manitoba, the Dominion Land Survey laid out a grid of 6-mile square townships beginning in 1871 to facilitate agricultural settlement. Because the survey lines attempted to impose a flat Cartesian grid onto the spherical surface of the Earth, north-south meridian lines converged as they moved northward. To prevent cumulative alignment errors, surveyors established east-west correction lines every 24 miles. Along these correction lines, north-south section roads jog abruptly to the east or west by up to 300 meters. This geometric necessity created thousands of right-angle offsets across provincial highways and rural municipal roads. Drivers traveling north on provincial roads encounter these sudden offset turns at regular 24-mile intervals, where the abstract math of 19th-century geodesy directly forces human transit to adapt to planetary curvature. What happens when these physical boundary lines and technical fixes face a structural change in the surrounding environment? Item 6. Ontario. In the southern Canadian Shield of Ontario, beneath 60 meters of post-glacial lacustrine clay and dense mixed forest, lies the Kidd Creek Mine near Timmins. Discovered in 1963 by airborne electromagnetic surveys flown by Extol Mining, the ore body showed up as a massive ground anomaly indicating high electrical conductivity. When drill cores extracted from 400 meters depth revealed massive copper and zinc sulfides, geologists recognized a preserved volcanic-hosted massive sulfide deposit formed 1.7 billion years ago on an ancient ocean floor. Underground mining eventually descended to over 2,400 meters below surface, making it one of the deepest base metal mines in the world. At that depth, ambient rock temperatures reach 45 degrees Celsius, and high lithostatic pressure causes sudden rock bursts, where brittle volcanic tuff fractures violently into excavation tunnels. Mining engineers rely on microseismic monitoring networks of geophones installed throughout the rock mass to track acoustic emissions in real time, predicting unstable stress fractures before failure occurs. Item 5. Quebec. In northern Quebec, the Manicouagan impact structure forms a nearly circular ring 90 kilometers in diameter, clearly visible in satellite imagery and shuttle photography. For decades, the concentric depression was mapped as a structural basin or volcanic complex, until geological surveys in the late 1960s analyzed shock metamorphosed minerals in the bedrock. Petrographic examination of drill cores revealed multiple shock lamellae and quartz grains, and fragments of melted target rock containing high concentrations of siderophile elements like iridium, proving an extraterrestrial origin. Isotopic dating of impact melt sheets using potassium-argon and uranium-lead methods established that a meteorite approximately 5 kilometers in diameter struck the Canadian Shield 214 million years ago. The resulting crater was subsequently modified by successive continental ice sheets during the Pleistocene epoch, which scoured the central uplift and carved the inner annular trough now flooded by the Manicouagan Reservoir. Item 4. New Brunswick. Along the Fundy coast of New Brunswick, the maritime cliffs near St. John expose a complex tectonic suture zone known as the Avalon Terrane. For generations, regional geologists debated how ancient volcanic arcs and sedimentary sequences from entirely different crustal plates were welded together along the Cobequid-Chedabucto fault system. The definitive proof came from high-resolution seismic reflection profiling conducted by Lithoprobe, a national geoscience research project that sent controlled acoustic waves deep into the Earth's crust. By recording the reflected sound waves with surface seismographs, geophysicists imaged the deep crustal architecture down to 40 kilometers depth. The seismic profiles revealed that tectonic compression during the Paleozoic era had thrust dense oceanic crust over continental margins, creating a deep subsurface fault network that continues to generate low-magnitude seismic tremors across the Bay of Fundy region today. Item 3. Prince Edward Island. The rolling red sandstone landscape of Prince Edward Island appears structurally uniform, yet high-resolution airborne magnetic surveys conducted by Natural Resources Canada revealed a hidden geologic boundary crossing the center of the province. The survey data mapped a sharp linear magnetic anomaly tracing the extension of the Avalon and Cobequid fault zones beneath the sedimentary cover. Because the surface bedrock consists entirely of soft Permian and Carboniferous red sandstone eroded by glacial action, these deep structural lineaments leave no direct topographic expression on the surface. Instead, hydrogeological testing and deep water well drilling logs show that these fracture zones control regional groundwater movement through the sandstone aquifer. Municipal water boards in Charlottetown rely on electromagnetic borehole logging to trace these hidden bedrock fractures, ensuring municipal wells intercept permeable fracture channels rather than dense, non-productive rock. What happens when these subsurface structural controls intersect with changing marine conditions along the eastern coastlines? Item 2. Nova Scotia. In Sydney, Cape Breton Island, the Mugga Creek estuary harbored the Sydney tar ponds, widely documented as one of Canada's most complex hazardous waste sites. From 1900 to 1988, the Dominion Iron and Steel Company coke ovens deposited an estimated 700,000 tons of toxic sludge and polycyclic aromatic hydrocarbons directly into the tidal estuary. Early remediation proposals considered dredging and offshore disposal, but environmental risk assessments warned that disturbing the tidal sediments would release volatile organic compounds into the atmosphere and surrounding harbor water. Between 2007 and 2014, the Government of Canada and the Province of Nova Scotia completed a $400 million remediation project using solidification and stabilization. Engineering crews injected cementitious binding agents directly into the soft estuarine sediment, turning the liquid sludge into a solid, low-permeability monolith. The consolidated block was then covered with a multi-layer impermeable geomembrane and clean soil cap, transforming the tidal mudflat into open hearth park. Groundwater monitoring wells surrounding the site track leachate levels, confirming that the trapped hydrocarbons remain encapsulated beneath sports fields and walking trails. Item 1. Newfoundland and Labrador. At Bell Island in Conception Bay, 4 extensive iron ore mines operated beneath the seabed from 1895 until 1966. The Wabana iron ore deposits consisted of hematite beds dipping gently beneath the ocean floor, where miners excavated workings extending over 3 kilometers from the shoreline at depths up to 400 meters below sea level. When mining operations ceased in 1966, the mechanical pumps were turned off, allowing seawater to flood more than 100 kilometers of underground drifts and shafts. The flooded mine network now holds an estimated 15 million cubic meters of water, maintained at a stable temperature of 8 degrees Celsius. In 2016, a team of specialized cave divers, working with Memorial University researchers and robotic underwater vehicles equipped with multi-beam sonar, began mapping the flooded subterranean chambers. Acoustic mapping revealed that despite 6 decades of submersion, structural pillars remain intact, though isolated roof collapses have occurred near fault intersections. The flooded workings represent a closed geothermal reservoir, prompting municipal studies to evaluate using heat exchangers to tap the constant water temperature for district heating on Bell Island. What overarching pattern emerges when all these local industrial and geological records are laid side by side across the map? What kept these phenomena hidden for so long was not their remote location, but the assumption that an official administrative boundary or a completed geological map sheet represented a closed physical system. Surveyors and environmental engineers mapped individual municipal boundaries, mining concessions, and regional watersheds as isolated units, missing the deep structural connections that span multiple jurisdictions. Today, baseline geochemical sampling, airborne geophysics, and satellite radar interferometry continue to reveal unrecorded subsurface displacement, abandoned mine shafts, and legacy contamination plumes across every province and territory. Many historical underground mine workings remain completely unmapped, their spatial boundaries preserved only in private corporate archives or lost to surface collapse. The official map sheet always presents a finished surface, but the geology beneath it remains in constant, measurable flux. Which site or anomaly in your own province or territory has always seemed the most overlooked? Or which of these 13 cases surprised you most? Share your perspective in the comments below, and subscribe to follow our continued geographical investigations across the country.